Hi everyone, continue on the subject of gas behavior to cover for well control IWCF level 3 and level 4. We'll examine the pressure regime in the well bore while the well is under shut-in with gas influx migration from bottom to surface. There are 4 places you need to know how the pressure is progressing. First is casing pressure, second is drill pipe pressure, third is the casing shoe pressure, and the last one is bottom hole pressure. Let's dive in right now. See in here, pressures all increasing. But how are we going to explain for that? All right, so this is an inclined well, not horizontal well, right? So the well is shut in, gas influx at the bottom. Right, you will have initial shut-in drill pipe pressure, initial shut-in casing pressure. All right, so as the question they ask you, what will happen to all 4 pressures? Drill pipe pressure, casing pressure, shoe pressure, and bottom hole pressure. All right, will they be staying the same? Will they be increasing or will they be decreasing? So initially at shut-in, you know that the formation pressure is acting against the well bore. So the bubble pressure means the pressure inside the bubble equals the formation pressure. We call it PF, right? So at shut-in, we have a balanced system. Bottom hole pressure equals formation pressure, equals the pressure inside the gas bubble, equals the shut-in drill pipe pressure plus the mud hydrostatic pressure inside the drill pipe, equals the shut-in casing pressure plus the mud hydrostatic pressure above the gas bubble plus the hydrostatic pressure of the gas bubble. That's the equivalent system. But if we leave the well like that, gas is lighter than mud. It will percolate up, right, and things will change. As we saw before, all 4 pressures will increase. But how are we going to explain for that? All right, as a gas bubble is percolating up to surface, it does the following. Number 1, it brings the formation pressure to surface with it. So therefore, the casing pressure gauge here on surface, you will see increasing. All right. That formation pressure inside the gas bubble will act throughout the well bore system. It acts to the shoe, it acts against the bottom, it acts inside the drill pipe pressure. So therefore, you will see the drill pipe pressure gauge increasing. All right. And the reason you will see more increment in bottom hole pressure because as mud percolates up to surface, it displaces more mud down below the gas bubble. Therefore, more hydrostatic pressure from the mud is acting against the bottom hole pressure. All right. So the answer is all 4 pressures will increase. And the pressure increment delta P is the same for all until the gas bubble reaches surface. Now the next question, more challenging. They ask you, okay, once the gas is at surface, all right, what do you expect to see casing pressure gauge? All right, what do you expect it to show here? Casing pressure gauge. Yeah, will it show initial shut-in casing pressure? We know not, because we know once gas reaches surface, casing pressure will increase. Therefore, initial shut-in casing pressure is not our answer. Will it show formation pressure? Will it show initial shut-in drill pipe pressure? For sure, initial shut-in drill pipe pressure is even less than initial shut-in casing pressure. So this is not our answer. Or will it register the mud hydrostatic pressure? So we have 2 options left to figure out. All right. Now we said before, once the bubble reaches surface, it carries the formation pressure PF with it. So the casing pressure gauge is installed right at the surface at the choke, right? So it will see that pressure right away. So therefore, the answer is PF. The casing pressure gauge will show PF formation pressure. Now, the same thing, but they ask you, what do you expect to see drill pipe pressure gauge? Okay, what value will it show? Will it show initial shut-in casing pressure? Because we know that initial shut-in casing pressure is higher than initial shut-in drill pipe pressure. So we know that once a gas reaches surface, all right, it carries the formation pressure PF with the two surface. So therefore, that PF, all right, will it be shown on the drill pipe pressure gauge? Yes. You know why? Because that PF acts throughout all the way down against bottom and inside the drill pipe to the surface. Therefore, we will see that formation pressure register on the drill pipe pressure gauge. All right? And now next question. Once gas is at surface, they are curious to see what the pressure will be shown, or will, what do you expect to see if you install a pressure gauge at the casing shoe. All right, they give you more options now. Initial certain casing pressure, formation pressure, initial certain drill pipe pressure, or mud hydrostatic pressure, or MASP, or formation pressure plus the hydrostatic pressure of the mud from surface to shoe. Which one? All right, you may just go ahead and choose the longest answer. Well, sometimes it plays, sometimes it doesn't give you the right answer. It's better to understand why, okay? All right, as the gas bubble goes up to the surface, it carries formation pressure PF to the surface. We know casing pressure gauge will show PF. It's similar to the leak-off test or FIT. You impose an amount of surface pressure into the well. So this PF is similar to that one. It goes in there, it stays in the well, it acts throughout the well, it acts against the shoe. Okay, so the shoe will see for sure the first value is PF. So what else is acting against the shoe? We have the mud column below the bubble, the gas bubble, all the way from below gas bubble down to the shoe TVD, right? So that works out the hydrostatic pressure of the mud from surface to shoes. Well, somewhere about that, right? So the answer is number 6, right? Formation pressure plus hydrostatic pressure of the mud from surface to shoe. All right, next question, last one. What do you expect to see the bottom hole pressure? All right, initial certain casing pressure, formation pressure, or initial certain drill pipe pressure, or mud hydrostatic pressure, or MASP, or almost twice in the formation pressure. All right, the answer is almost twice, but how? Once the gas bubble is at surface, we have the formation pressure PF acting from top all the way down to the bottom. Okay, so we have PF, that's formation pressure. What else do we have? The bubble goes up to the surface, it has already displaced the mud from above it to below it. So below the gas bubble, we have full mud column in the annulus. That's almost the same, very similar to close to the hydrostatic pressure of the full mud column, right? So you sum up those two values, it's almost twice as much as the formation pressure. So the answer is formation pressure times 2. All right, that's how you interpret the pressure regime during gas migration under a shut-in well. Hopefully it does some good for you. We'll discuss more about gas migration in a non-shut-in well in the next clip. See you.